Hello dear students, welcome to my third class on Module 2 Properties of Integers. In my previous lecture videos, we discussed about mathematical induction and problems based on mathematical induction. So here we will be discussing about the recursive definition and problems on recursive definition. Okay, first let me explain what is recursive definition. So in describing any kind of sequences, commonly we'll be using two kind of methods. One is explicit method, one more is recursive method. Okay, in explicit method, the general term of the sequence is explicitly indicated. For example, the sequence is like an is equal to 2n I'm having. So I can represent that explicitly like a1, a2, a3, etc. like that. Okay, in recursive method, the first few terms of the sequence must be indicated explicitly, and the second part of the rule which will be enable us to obtain new term of the sequence. Okay, if the sequence from the terms are already known, must be indicated. So let me explain this while solving the problems clearly. So the problem is like find an explicit definition of the sequence defined recursively. So they have given some recursive definition. I want to represent this one explicitly. Okay. So like how means they have given the value of a1 is equal to 7, an is equal to 2an minus 1 plus 1. So we can see here. So this is for n is greater than or equal to 2. For example, if I replace n is equal to 2, I'll be getting what? 2 times of a1 plus 1. So it will become what? 14 plus 1, it will become 15 I will be getting. Like that. Okay. So now I'm going to expand this one by using explicit method. Okay. So they have given an is equal to 2 an minus 1 plus 1. Okay. So by the repeated use of the given recursive definition, I am going to expand this one like this. So I am going to take the an is equal to 2n minus 1 plus 1, but I need the value of an minus 1 also. So this is how means like I am going to take the equation now. Okay, we can see here. Now I want to find the value of an minus 1 from this equation. So in this equation, I am going to replace n is equal to n minus 1. So I will be getting what? An minus 1 is equal to 2 times of an minus 2 plus 1, right? Just I replaced n is equal to n minus 1 in this equation. So I got the value of an minus 1. So now I am going to replace this an minus 1 value here. So I'll be getting what? 2 times of an minus 1 plus 2, this equation, plus 1, I got it. Now again, I want the value of an minus 3 also. So an minus 2 also. So same thing again, to find the value of an minus 2 in the given equation, I am going to replace n is equal to n minus 2. So what I'll be getting what? An minus 2 is equal to 2 times of an minus 3 plus 1, right? Okay. So now I am going to replace this an minus 2 value in this place. I'll be getting what? 2 I am keeping as it is first. 2 I am keeping as it is. In the place of an minus 2 I am replacing 2an minus 3 plus 1 plus 1. 2an minus 3 plus 1. Okay. Plus 1 as it is. Okay. So on expanding these equations further, I'll be getting what? 2 into 2 into 2, 2 cube. Again 2 into 2, 2 square plus 2 into plus into 1 plus 2 plus 1 I'll be getting. So on expanding this equation for n minus 1 times, I'll be getting what? 2 power 2n minus 1 an minus of n minus 1 plus 2 power n minus 2 plus 2 power n minus 3 and so on plus 2 square plus 2 plus 1 I got it. Is it fine? So now on expanding this part, an minus of n minus 1, I'll be getting what? 2 power n minus 1 a1 plus 1 plus 2 plus 2 square plus 2 cube plus so on plus 2 power n minus 3 plus 2 power n minus 2 I'll be getting. Okay. So now by using the a1 is equal to 7 and the standard result of 1 plus a square plus a cube plus so on, I'll be getting what? I'll be getting the this equation as a power n minus 1 divided by a minus 1 only if a is greater than 1. Okay. So now I am going to incorporate this a1 is equal to 7 and this sequence in the above equation. I'll be getting what now? An is equal to 7 into 2 power n minus 1. So since here I am having 2 In the place of a, I will be replacing 2 here. I will be getting what? 2 power n minus 1 minus 1 by 2 minus 1. On simplify this, I will be getting 2 power n minus 1 by minus 1. So it will be equal to 8 into 2 power n minus 1 minus 1. I got it. So next is problem number 2. Obtain the recursive definition for the sequence an in each of the following cases. So first one, they have given an is equal to 5n, an is equal to 6 power n, third one is an is equal to 3n plus 7, fourth one an is equal to n into n plus 2, fifth one an is equal to n square, sixth one an is equal to 2 minus of minus 1 power n. So let me solve one by one. They have given an is equal to 5 power n. The first step is what? We have to represent it in terms of explicitly. So like first, if I replace n is equal to 1, I will be getting what? a1 is equal to 5, a2 is equal to 10, a3 is equal to 15, a4 is equal to 20. Fine? Okay. So now, first let me take a1 is equal to 5 only. Okay. Next, I am going to represent this in terms of recursive definition now. How I can make means, I can write an is equal to an minus 1 plus 1 plus 5 I will be getting, because here a1 is equal to 5 is there, a1 is equal to 5 is there, a2 is equal to 10, a3 is equal to 15, a4 is equal to 20. The difference between the each term is 20 here, sorry 5 here. So what I can make now, I can rewrite the equation like an is equal to an minus 1 plus 5. So like for each term, if I add 5, I will be getting same value again. So this equation will be applicable only for n is greater than or equal to 2. Like how means, if I replace n is equal to 2 here, I will be getting what? A2. A2 is equal to a1 plus 5. a1 is already 5 is there, I will be getting a2 value. So same thing I can find a3 again. For n is equal to 3, I will be getting a3. a3 is equal to a2 plus 5. a2 is 10. So I will be getting 15 here. So this is called recursive definition of the given equation. Okay. So next one. an is equal to 6 power n. So first let me expand this at n is equal to 1, 2, 3, 4. a1 is equal to 6, a2 is equal to 6 square, a3 is equal to 6 cube, a4 is equal to 6 power 4. So almost commonly is there, like 6, 6 square, 6 cube, 6 power 4. Okay, so now we can rewrite this equation like, so first let me take the first value as it is, a1 is equal to 6, a2 I am going to write like, so the difference we can see, here only 6 is there, here 6 into 6 I can make, here 6 into 6 square I can make, here 6 into 6 cube I can make. So like I can read the equation like a1 is equal to 6, an plus 1 will be equal to 6 into 6 power n I can, sorry, 6 into an I can make it. Same thing, because an will be equal to 6 power n only now. Yeah, so I will be getting an plus 1 is equal to 6 into an and an will be equal to 6 power n. So same thing, on expanding this I will be getting this equation only. This is for n is greater than or equal to 1. This is called a recursive definition for the given equation. One more, n is equal to 3n plus 7. So first let me expand this for n is equal to 1, 2, 3. a1 is equal to 10, a2 is equal to 13, a3 is 16, a4 is 19. Okay. The difference between each sequence is 3 I'm having, right? Each term is 3 is there. So what I can make? I can make the equation like an is equal to an minus 1 plus 3 I can make it. So we can read this as first term, we have to keep as it is, a1 is equal to 10 and an will be equal to an minus 1 plus 3 for n is greater than or equal to 2. So this is called so this will be the recursive definition for the given sequence n is equal to 3n plus 7. So next one, fourth one, an is equal to n into n plus 2. Okay, so expanding this I will be getting what? For n is equal to 1 to 3, a1 is equal to 3, a2 is equal to 8, a3 is equal to 15, a4 is equal to 24. The difference between a1 and a2 is 5, a2 and a3 is 7, between what is that, a3 and a4 is 9. So this is highly complicated to expand the recursive definition here. So what I can make means, I am going to find the difference between each term now. So a2 minus a1 will be 5. Okay, I can rewrite this 5 as 2 into 1 plus 3 I will write it. Okay, same thing for a3 minus a2. What I can get, I'll be getting 7 here. So 7 I can make like 2 into 2 plus 3. I'll be getting 7 here. So same thing for a4 minus a3 also. I'll be getting 9. So 9 I can make like 2 into 3 plus 3. It will be 9. So now the sequence will be how? An plus 1 minus an is equal to 2n plus 3. I can make it because here 1, 2, 3 it's varying actually, so I can make like 2n plus 3. So therefore an plus 1 will be equal to an plus 2n plus 3 for n is greater than or equal to 1. So hence a1 is equal to 3 and an plus 1 is equal to an plus 2n plus 3 for n is greater than or equal to 1 is the recursive definition of the given sequence. Next is an is equal to n square. So a1 will be 1, a2 is 4, a3 is 9, a4 is 16. So the difference is not common here. So again we have to find the difference between each term. a2 minus a1 is 3. So 3 I can make like 3 into 2 into 1 plus 1 I will write. 9 minus 4 is 5. I can make like 2 into 2 plus 1. I'll be getting 5. 16 minus 9 is 7. I'll be making like I can make like 2 into 3 plus 1. So the sequence will be how? An plus 1 minus an is equal to 2n plus 1 I'll be getting. Therefore an plus 1 is an plus 2n plus 1 for n is greater than or equal to 1. So hence a1 is equal to 1 and an plus 1 is equal to an plus 2n plus 1 for n is greater than or equal to 1 is the recursive definition of the given sequence. Next last one, an is equal to 2 minus minus of 1 power n. So let me expand this. For n is equal to 1 to 3, a1 will be equal to 3, a2 is 1, a3 is 3, a4 is 1. So the values are varying again here, 3, 1, 3, 1 like that. So now first let me find the differences. a2 minus a1 is minus 2. I will write minus 2 as 2 into minus 1. a3 minus a2 is 2. This will be like 2 into 1. a4 minus a3 is minus 2 again. So again 2 into minus 1. So I can write this one as an plus 1 minus an is equal to 2 into minus 1 power n. I can make it. So an plus 1 will be equal to what? An plus 2 into minus 1 power n. So hence the a1 is equal to 3 and an plus 1 is equal to an plus 2 into minus 1 power n for n is greater than or equal to 1 is the recursive definition of the given sequence. Problem number 3. The problem is given like the Fibonacci numbers are defined recursively by f0 is equal to 0, f1 is equal to 1. And f1 is given like fn minus 1 plus fn minus 2 for n is greater than or equal to 2. Evaluate f2 to f10. So from this one we have to find the Fibonacci numbers. So given that fn is equal to fn minus 1 plus fn minus 2 for n is greater than or equal to 2 and f0 is 0, f1 is 1 here. So now I'm going to find the value of f2. So at n is equal to 2, I'll be getting f2 is equal to f1 plus f0. It is given by 1 plus 0 will be equal to 1. At n is equal to 3, I'll be getting f3. f3 is equal to f2 plus f1 will be equal to 1 plus 1. It will be equal to 2. So this f2 is obtained from previous value. f4 is given by at n is equal to 4. f4 is equal to f3 plus f2 is equal to 2 plus 1. This 2 is from previous f3. It will be equal to 3. f5. So at n is equal to 5, I'll be getting f5 is equal to f4 plus f3 is equal to 3 plus 2. This 3 is obtained from f4. It will be equal to 5. At n is equal to 6, I'll be getting f6. f6 is equal to f5 plus f4. It will be equal to 5 plus 3. It will be equal to 8. At n is equal to 7, I'll be getting f7. f7 is equal to f6 plus f5 is equal to 8 plus 5 is equal to 13. f8. At n is equal to 8, I'll be getting f8. f8 is equal to f7 plus f6 will be equal to 13 plus 8 is equal to 21. f9. f9 is equal to f8 plus f7 is equal to 21 plus 13 is equal to 34. f10. f10 is equal to f9 plus f8 is equal to 34 plus 25 will be equal to 55. So this sequence found by the Fibonacci number will be called as in Fibonacci sequences. So these all numbers like what is the numbers here? 1, 2, 3, 5, 8, 13, 21, 34, 55. So these all numbers are called Fibonacci numbers and the sequence will be called as in formed by this Fibonacci number will be called as in Fibonacci sequences. Thank you.